Perfect. We'll talk about the JDK, and I do have some debugging stuff because, as you're probably aware, debugging on the JVM inside of NeoVim is maybe not the easiest thing to do. But thank you so much for having me. My name is Chris, and today I'm going to be talking to you about language-tailored plugins, an experience like no other. So a little bit about me, as they mentioned a little bit already. You'll find me primarily working in Scala tooling, one of the maintainers of Metals, which they said, which is the Scala language server. And then I wrote NeoVim Metals shortly after the native LSP support was added into NeoVim. I have a podcast called Tooling Talks, which ironically also talks about Scala tooling. So you're seeing hopefully like a trend here that, yeah, I work a lot in Scala tooling. And you can find this talk and a bunch of other talks that I've done at my website there under talks. Professionally, I work at a company called Lunatech, which is a JVM consultancy here in the Netherlands. And we also have offices in Belgium and France. But the kind of cool part about my job is while I work for Lunatech, they just sort of fully give me to the Scala Center, which is a nonprofit, which is primarily in charge of like education for Scala. And then also we maintain some of like the core tooling for the ecosystem as well. So I get to, work on open source Scala tooling full time basically, which is pretty awesome. I know I see messages about being in Dutchy, but I'm actually not a Dutchy. I'm originally from the US. I just live in the Netherlands, so sorry to disappoint. But let's talk about language-tailored plugins. And you might be thinking, well, what do you mean when you say language-tailored plugins? And for example, NeoVim Metals is one for Scala, which is what my talk is about. There's also others such as NeoVim JDTLS. I would say that this is probably like the first one that we saw appear, you could say. I also want to give a big special thanks to Matthias because he was like a huge inspiration actually for me when I was getting started with NeoVim Metals. And all of his projects have just been like incredibly clean, really well thought out. He is super easy to talk to and helps contributing to his projects. So just like a huge thank you to Matthias there. There's also Rust tools, which is for Rust, and then also Flutter tools, which is for Dart. And you'll probably also notice a pattern here that some of these are either harder to set up or they take maybe there may be harder languages to work with without more things. But we're going to look at this from two different perspectives. We're going to look at it from a user's perspective, and we're going to look at it from an author's perspective. So let's start from a user's perspective. So if you're like me and you're like getting started with a new language, the first thing you'll probably do is you'll just look up that language in NeoVim LSP config. Like I've already done it a handful of times where like, I need to use X language. So I just dive into there and I figure out how to install it. And normally it is as simple as this, right? You require LSP config, you name your server. In this case, we'll do Metals. Then you'll call setup. And that's it if you don't want any extra setup in terms of just setting up NeoVim to use your language server. And then you also need to install that server, obviously. So for Metals, that case is you can use something called CoreCA, which is like a tool that you can install Scala or JDK applications on your machine. And you'll just install Metals. Then you'll add some key bindings like hover, which is, I'm sure something everybody uses. And that's kind of it. That's all you really need to do to just like get going. But unless your server has more to offer, or it requires more in-depth setup, and then you're kind of out of luck a little bit. For example, we'll go over a couple things that I would say like the base LSP config doesn't cover all that well. And one of those things is LSP extensions. And not tons of servers make use of these, but servers like Metals, for example, do. And if you're not familiar with these at all, like you have the normal kids on the block, right? Like you have text document hovers, you have published diagnostics, references, et cetera, kind of like all of the core things that you would expect a language server to have for you to have support in the editor. And if it really doesn't have those, then you kind of like question like the usefulness of actually having that language server. But there can be other ones as well that are custom to language servers. And I'll give you some examples of this. So for an example, in Metals, we have one called publish decorations. And what this does is it allows you to open any .worksheet.sc file. You could put some code in there and you can save it and you can get live evaluations of that code right in your editor. And what you're seeing here is actually using X marks and virtual text. And if you put some print lines in there or you have really long outputs, the hover that you're seeing here isn't actually the LSP normal hover. It's another hover, which gives you the output of the line. And then you can still use the normal hover. But all this is done with a special handler called publish decorations, which is unique to Metals. So you can't just do LSP config, install Metals, and get this to work necessarily. There's also special workspace execute commands that a lot of editors have. I think I looked the other day in the LSP config and I saw like maybe a small handful of these were actually added to LSP config for certain servers. But for servers like Metals, we actually have over 40 different of these commands just because there's like tons of different things you can do. So for example, what you're seeing here on the screen right now is that you have a piece of Scala code, which will turn into a class file because it will run on the JDK. And let's say maybe you want to understand what that class file looks like decompiled into Java, and you can do that. So this is just me in a Scala 3 file, wondering what that code looks like decompiled after it becomes a class file. And right away, I can do that right in my editor. And this is done as well with some more special handlers to handle that, handle those special files. Like this is called the CFR viewer inside of Neovim Metals. Or there's sometimes complete custom protocols, not just custom handlers, like the TVP, which is the tree view protocol, which is a protocol in Metals. And don't get confused, because I know everybody sees trees and they sort of think like File Explorer, but this is similar, but not. And what's actually happening in the GIF here is that I'm going to a definition of a dependency method called log. Then I'm wondering where in my external dependencies that's defined. So I'm revealing it in the tree. So I'm actually jumping into external dependency. Then I'm looking at all the other methods or objects or classes in that external dependency, and then I can jump to them right in the other side of the editor. So I typically use this as a way to like explore an API of an external dependency. And yeah, that's how I use it. But it's an entire protocol. So there's maybe like 5 or 6 different LSP endpoints that would need to be implemented in order for this to work. And then it also just allows for smoother integrations with tools like Neovim DApp. So as you can see here, we have a simple piece of Scala code, which is just printing hello world. And there's some code lenses here that I'm triggering, and I'm clicking run, and it just auto magically runs and prints out hello NeoConf. So that's pretty rad. But if you are thinking about language-specific plugins that don't use Neovim LSP config, you must be thinking like, oh, these are really hard to set up probably. You have to do a whole bunch of extra things. I'm really used to just doing the simple require Neovim LSP config and then set up server, and then that's it. But that's not really the case. So for example, with Neovim Metals, it's still really simple to set up. You just use Scala Meta Neovim Metals. It requires plenary, so then we use that as a dependency as well. And then you create a file type auto command that can get started on Scala, SBT, Java. Java is sort of optional because we have very limited Java support compared to something like Neovim JDTLS. And then we have a initialize or attach function that gets started. And that's it. Like that's how you'd get started. So it's really not that different. What about debugging? You want some debugging, and there was jokes made about like how much it sucks to set up debugging on the JVM. Well, as you can see here, we have the same auto type command, but we just have one line added, which is the Metals config now, instead of being an empty table, is an actual config. And up top, you see that we require a bare config. And then we just call setup DApp, and that's it. And now you automatically have debugging in a Scala project as long as you have Neovim DApp installed. So without much extra work, you're getting quite a bit more, I would say. And if you're like me also, I really want to look at it from an author's perspective, because as a user, obviously, I want to make sure things are easy for me to use. But as an author who's trying to provide language support for a specific language through a server, like I want to make sure that all editors can use it, and that it's specifically easy to use in Neovim. So from an author's perspective, using Vim LSP start is amazing. And I want to go over a few different things, because I think people sort of have the false impression that if you're going to like fully manage the server lifecycle in Neovim, it's really difficult. And that's totally not the case. Like, it's kind of amazing how easy it is to manage a server like the entire lifecycle of the server just by using Vim LSP start. And when Neovim Metals first got started, it wasn't quite this easy. There were some extra steps that you had to do, where you would have to check if there was like a server that was already attached to the buffer. And if there wasn't, then you wouldn't attach it. But if there was none, then you would finally attach it. So you had to have like all of this logic that you sort of kept either that information, or you would have to do a lookup every time you opened a file, where now you don't need to do that at all. You literally just call LSP start, you give it a config, and it takes care of all that for you, which is pretty crazy. So earlier, you saw the initialize or attach inside of the auto command. And here you sort of see what happens. We have the option to kind of cache some config. So that's what we're doing right away. We're checking to see if it's an invalid Scala file. And what this does is it checks to make sure that, like, sometimes if you're using Git plugins and you see like a Git like merge tool thing, like the file type will still actually be Scala instead of like whatever custom type of thing is happening. And we don't want to attach to those types of buffers. So we make sure it's not that. We add some commands. We make sure the user is not in disabled mode. We validate the config. We also make sure we give like I would say much nicer helpful messages if the config is invalid or what's missing from it and what's available to them. And then we start it. And that's really it. And this is like all you really need to like have a server. So easy. You also have full control over the install process. And I know you'll hear some people say like, well, NeoVim's not an installer or a package manager. And that's very true. It's not. But it can be a really nice interface to your package manager. And in this case, I've personally had times, for example, with LSP config, where you don't necessarily know, like, I thought I installed this, but I don't really see anything working. So maybe it's installed, maybe it's not, or maybe it's installed, but it's not working because I go to definition doesn't work, but I don't get any errors. So I have no idea. So having your own plugin like this gives you full control over that process. So like in the case of NeoVim Metals, like if they don't have Metals installed, they get a really nice message like this. It just says, hey, issue this command. It will install Metals for you. It won't actually do the installation. It will use the underlying tools to do that. So if you wouldn't have CoreCA installed, it would also warn you about that and say, hey, we also need to install Metals, but you need to install this other tool first because we can't install Metals without it. Now let's talk about LSP extensions a little bit because I showed you a couple of them, right? So publish decorations. From a author perspective, it's so easy to add these to NeoVim. And I think something that people might not know as well is that the way that these handlers work in NeoVim for things like hover or go to definition, it's literally exactly the same when you have a custom LSP extension. It's no difference whatsoever. You just give it inside of the module in the handlers table, and you add some logic to it. And here you see the one for worksheets. We have a decoration module that we're calling here, and that's what's doing most of the work. But you get the idea. We check if there's no error. We grab the URI and the buffer number from that URI. We clear the previous decorations, and then we set the decorations in that buffer, and that's it. And this is all we have to do. And this module, or this handler table rather, is inside of the config object that we pass to LSP start, and that's it. Like that's all you have to do. So it's really easy actually to add custom endpoints like this, or override existing ones as well. What about special workspace execute commands? So this is really similar to what you'll actually see in LSP config sometimes, is you have a helper function like this called execute command. And in the current buffer 0, we're just going to execute a workspace execute command. You have some parameters that you're going to give with it. And then you have an optional callback that, depending on the result that you get back from the server, does some stuff. And in Metals, like I said, we have like 40 of these. So there's all sorts of stuff. Like we have an analyze stack trace one where it takes whatever's in your register, which is hopefully stack trace, sends it to the server analyzes it, sends it back. And then you have code lenses that you can jump to whatever part of your code the stack trace is in. And we have switch BSP, which is the build server protocol. So like and when you're doing Scala on the JVM, you could have multiple different build servers that are actually compiling your code, and this will allow you just to switch between them or connect to one. So there's a bunch of these. I also talked about smoother integrations with NeoVim DApp. And I want to reiterate that for languages like Scala, this is super, super important because debugging on the JVM kind of sucks. Because in reality, it actually looks something like this. And I actually wrote a big blog post about this, how it works in Scala, specifically with Metals. And this is probably pretty small to see, but just to give you like a rundown, like we saw earlier that if you want to debugging inside of your configuration, you just call setup DApp. And what that's actually doing is telling Metals, hey, this client supports debugging. And we want to make sure we set that correctly or not set that correctly. And we don't turn it on all the time because in the back end, Metals has to do a whole bunch of extra stuff to ensure what are the main methods? Can I get them from the build server? Can I search this file? A whole bunch of stuff. So to kind of give you an idea of the flow, setup DApp is called, which makes sure that when the initialize process in LSP happens, it happens correctly. Then the user triggers DApp continue, and they'll have to have like a Scala entry for that. And once that happens, it will issue a workspace execute command, like we just saw a little bit ago, called Metals debug adapter start. That will go all the way to the server, and the server will verify that the class that they executed that command in has a main method, unless they're using code lenses. That's a whole different flow in itself. But if they aren't using the code lenses, it will make sure that the current file has any main methods or tests. If it does, it will send a request to the build server. So here's a whole, like now we're like an entirely different protocol, where the front side, we were sort of on LSP world. And now on the back side, we're on BSP, which is called the build server protocol. You could kind of think of it as like a sister protocol to LSP for building your code. So that will go to your build server. It will start a debug server. It will send the address back to Metals. Then Metals will forward it back to NeoVim Metals. And then finally, NeoVim Metals will have everything it needs to actually hand that off to NeoVim DApp and let it take over. So without having some type of like integration that's done inside NeoVim Metals, there'd be like no way for a Scala developer really to just take Metals and take NeoVim DApp and get it to work correctly. Because like Metals has to be initialized with correct things. It has to wait to get the address of the debug server, a whole bunch of different stuff. So it'd be really, really difficult for users to get this working without some extra help that NeoVim Metals offers them, for example. And that's the same thing with other tools as well. Like NeoVim JDTLS does something similar as well, I believe. So as an author, you get way more control over setup. You have an easy way to add server commands, especially if you have a ton of them, without having to like pollute the LSP config one. There's an easy way to add custom handlers for servers that have like all sorts of different custom endpoints or LSP extensions, and allows for like much tighter integration. So you don't have users just being like, I can't debug my Scala code with NeoVim DApp. NeoVim DApp sucks, because you'll always get people that will say stuff like that and blame like the wrong tools or the wrong things. So this will allow for like much tighter integrations to allow for stuff like that to work. And all that will lead to just like happier users. Like when users can set up stuff really easily, can get all the commands that they want, especially for today when you have a lot of language servers that have tons of really great features. And it's really sad that VS Code users seemingly get to benefit from all of those cool features, but then some of the other editors don't get to. And that was something in Metals that I was really passionate about personally, was that I wanted to make sure that anything that a VS Code user could do with Scala, for example, that we could do in Metals. And I'm pretty happy to say that like 99% of the stuff you can do in other editors, you can do in NeoVim. So it's pretty rad. So if your language has a dedicated plugin, you should go give it a try. If you're a Rust user or a Dart user or a Java or Scala user, you should totally give that plugin a try. If you are considering making one for your language, go give it a try. I hope to encourage you that it's not as hard as you might think. And there are totally different ways of doing this, right? Like NeoVim JDTLS and like the other ones that I showed you, we all chose to fully manage the lifecycle itself. But you don't necessarily have to do that. If you're just adding extra handlers, for example, you could just have a plugin that like takes advantage of the on-attach and just registers those handlers that way. NeoVim Metals does like a lot more stuff on setup, so that would be harder for us, and that's why we have our own plugin. But if you're considering making a plugin for your own language, go give it a try, and don't be afraid to fully